Very good evening, my dear friends from online and distance education of SRM program, the faculty of SRM, our dear program coordinator, Dr. M.L. Jnanadasan sir, and a very pleasant good morning to our guest speaker, Mr. Thiru Angayan from USA. I welcome you all to the international webinar on unveiling secure software design and advancements in cyber security trends. The very topic of this webinar prompts me to share a recent experience that happened to me. A few months back, my friends and I were spending some time together, and I got a message from my bank. My father has just deposited my current semester fee amount in my bank account so that I could pay my fees. While I sat there silently contemplating if I should immediately pay the fees or wait before my friends asked me for a treat for clearing all papers in my previous semester, something happened. I started getting a series of messages from my bank which said a few thousands were debited from my bank account. There was message over message over message, a debited message. And before I can even open and read all the messages, I realized that the entire sum that my father had gave me was debited from my bank account in total. I sat there in absolute horror, wondering which city I should run away to before my father hears about this. Tears welled in my eyes, not knowing what to do, was coming from my friends. And yes, my friend had pranked me by sending fake messages using a software created to prank others. I wanted to be very sure, so I checked my balance in the mobile banking app, and there it was, the entire sum that I received plus few paisas that I managed to save. I was relieved. After all, I was not going to be homeless. In my case, it was a mere prank by my friends to that happened all across the globe. Say Facebook, Instagram, and Meta. Today, internet is deemed as a necessity and not a luxury. Does it have an evil dark side? We will hear more about from our guest speaker, Mr. Thiru Angayan, who is an engineering manager and EME certified in advanced cybersecurity working in Texas Instrument in USA. I request everyone to mute themselves during the webinar and to post any questions in the chat box, which will be answered by our guest speaker in a short question and answer session after the webinar. I would also like to recognize the efforts of a fellow student and a friend, Mr. Adrian Gilby, who is unfortunately not joining today. He for his efforts in ensuring that the webinar runs smoothly. And ladies and gentlemen, esteemed viewers, and my fellow students of SRM, it is with great pleasure that we extend a warm welcome to today's distinguished guest, Thiru Engayan sir, to what promises to be an enlightening webinar on unveiling secure software design and advancements in cybersecurity trends. We are privileged to host an industry trailblazer today, a veteran in embedded software engineering, connectivity protocols, and advanced software security validation. Mr. Thiru's expertise has been pivotal in shaping standards across complex software ecosystem. Mr. Thiru Angayan's career trajectory spans over 30 years, marked by in-depth specialization in strategic software quality assurance for high-stake applications. His expertise covers an impressive array of technical fields, including power management algorithms, low-level firmware engineering, memory management intricacies, and embedded systems validation. His work, particularly across compliance certifications for embedded systems, is instrumental for ensuring robust, secure, and scalable software in regulated environments. With a Master of Engineering degree in Applied Electronics from the Government College of Technology in Coimbatore, obtained in 1993, Mr. Thiru has a rock-solid foundation in core electronics and computational theories, which he has continuously evolved to keep pace with modern technological demands. His recent attainment of Advanced Cybersecurity Certificate from Stanford University in 2023 underscores his relentless pursuit of knowledge in the face of rapidly evolving security threats. Mr. Thiru's ongoing research focuses on critical aspects of secure software design, delving into topics such as secure boot processes, cryptographic validation mechanisms, and the minimization of attack surfaces in low level code execution. His work on battery life optimization and charging characteristics, particularly within the mobile and the IoT devices, exemplifies his ability to integrate secure functionality with performance efficiency, creating solutions that are both resource conscious and resilient against potential vulnerabilities. Outside his professional domain, Mr. Thiru dedicates his efforts to philanthropic engagements, notably with organizations that ensure educational opportunities for students from socially and educationally marginalized backgrounds. His commitment to inclusive education extends to his contribution to Khan Academy, where he works to translate educational content into Tamil, breaking language barriers to provide equitable learning access to millions. When he's not immersed in software and security frameworks, Mr. Thiru channels his energy into marathon hiking and exploring global cultures. A true polymath, he balances his technological rigor with a profound commitment to societal impact and personal exploration. Today, we are honored to gain insights from Mr. Thiru on secure software architecture and how cutting edge cybersecurity trends like quantum resistant cryptography, zero trust architecture, multi factor authentication protocols, and AI driven anomaly detection are reshaping the future of software security. His extensive knowledge and dedication to building a safer digital landscape are sure to offer invaluable perspectives. Please join me in welcoming Mr. Thiru again to the stage as he leads us through the intricacies of secure software design and shares his vision for advancing cybersecurity in an era of unprecedented digital transformation. Welcome and over to you, sir.
Oh, that is overwhelming. Thank you so much, Shamima. And thank you, Dr. Das, for all the kind words and introduction about me. Considering the short amount of time we have, I would like to get into the topic right away. Um, the title here, Unveiling Secure Software Design and Cybersecurity, is really a vast ocean-like topic. Trying to do some justice to this in like 40 minutes is almost close to impossible. So, what I want to really do here is probably stick to some fundamental concepts and some examples of how these concepts be applied in the latest cybersecurity world. Let me start sharing my slides first. All right. Can you guys hear me okay? The audio is okay now?
Yes, sir.
Good. So, as I said, this topic is such a vast topic, and I was having this dilemma. What should I do? Should I take a particular small little area like cryptography or artificial intelligence focused cybersecurity and go deep dive into that? Or should I stay with like to your fundamentals, make the fundamental concepts very clear and go from there? So I was talking to Das, Professor Das, who is my friend. Hey, what is the level of um audience knowledge about cybersecurity? Should I do this way or that way? He came up with some kind of saying, hey, they have both students and also there are working professionals. So I want both of it. So he was a little greedy on that. He want both fundamentals and also want the advanced topic. And I'm sorry, Das, we can't do both of that. Okay. So let me start with the fundamentals and then probably I will dwell into some advanced also as the time permits. But I promise you guys one thing, right? So once we have this topic, say whether it is fundamental or the basics I talk to you, if you still hold a lot of interest in this, I will get into the next, maybe like in another couple of weeks, to have a much more pointed, a specific topic where we can deep dive into. Okay. So with that note, let's get on to the things here. So this is kind of a disclaimer here. Whatever I talk into this seminar today is my own opinion. I'm not representing Texas Instruments on that because there are some privacy and confidentiality thing, the agreement I have with the company. So I'm not talking on behalf of my company, but I am talking on behalf of me. All right.
Perfect.
Good.
Okay.
Got it? Yeah.
Right.
So, as I said, the agenda here, I'm going to just introduce the cybersecurity, the scope, and the foundational concept, which I consider there are like 7 pillars of the security concepts, and maybe the types of attacks that's happening all over the world. As Shamima was kind of explaining to that her experience, though it was a prank, this is happening really in the world. People are like, depleted of their bank account just like that, and with all the little carelessness, we will get there. All right. And then I will talk about the secure design principles. Again, this is going to be the fundamentals of secure system design. And we will get into one example of how an application state can be manipulated to have an attack the hacker. Can you see the introduction one now?
Yes,
The
sir.
fourth
Yes, sir.
slide? Okay, good, good. All right. So the slide is shown now, but I already talked about it. Okay. So I'm not going to repeat it considering the time. So we'll be doing the fundamental concepts, the types of attacks, and the security principles. And then I will give an example of how an application state is exploited by a hacker. Okay. So that's going to be the gist of this presentation today. So what is cybersecurity? It may be like a very lame question, but a lot of people get confused on what is this. Um, if I have to say in one single sentence, it's protecting digital assets. But you need to know what is digital assets we are talking about. And expanding it a little further, cybersecurity is a technique of protecting your systems, devices, networks, and all of the data stored in the devices, right? So I want you to guys kind of stare at this little bit, at this screen where I have like bunch of pictures on it. So when we say cybersecurity, we need to understand what are we securing? What is we mean by the cyber or the internet? Is it your mobile phone, a laptop, or a banking system, or a cloud, or critical infrastructure, or your routers, or the fiber optics, or your tower? What is it? So it is all of it, right? So, so if I have to simplify the entire thing for your sake of fundamental understanding, the whole internet is just a computer talking to another computer, or maybe a smart device talking to another computer through a web of infrastructures like a fiber optic communications, a wireless communication, combination of that in between so many routers and web servers, web clients, and all that. So when we say we are talking about cybersecurity, we actually mean all of this in one form or other. How a network is, we can secure a network, and how is an application is secured. There are millions of, when I say application, it may be an application in the mobile or it may be in the laptop. And the information or data security, cloud, where nowadays all the data and the information is stored in the cloud, which is like a remote computer server somewhere. Your bank's data may be in some other country, outsourced by Amazon Web Services, right? And the mobile security, almost everyone now we have a mobile phones, and how secure that is. So when we talk cybersecurity, this encompasses all of this, right? So how do I kind of get into any one of this? And even when we talk about the cryptography or AI applied here, without knowing how this whole thing works, it will be very hard and your knowledge will be shallow. So, my first advice to all of you if you really want to understand the cybersecurity, you need to understand to some extent how the internet works, how the protocols works, how the physical hardware is connected, how the towers, fiber optics, all of that is interplay in that. Okay. Once you have that grasp, then whatever I talk will make sense to you. Otherwise, it will be like when I say the cloud should be protected with the encryption of this and hash algorithm of that, you probably cannot have a grasp of what I am talking about, right? So I would recommend you guys to first take a first course in how the internet works, how the infrastructure is laid on, and then talk about that. So to that extent, I'm not going to explain to you now further more on that, and I'm going to go to the topic of the fundamental pillars of the security, the internet security. So I have kind of, when I was taking this course with Stanford, these professors were so adamant saying like, you want to first understand the fundamentals as clear as possible before making sense to understand the advanced topics of it. So there are 7 things here um, which we consider the fundamental pillars of the security. Number 1, the authentication, authorization, confidentiality, data integrity, accountability, availability, and repudiation. I will talk each of that. Okay. The first thing is the authentication, which you all may be familiar with. That is, you have to authenticate who you are and who you are talking to. So in the case of Shamima's example, when she's trying to access the bank, she may probably need a username and the password, right? So which is, there are 3 general ways we do that. That is something that you know, which is a password that you created, the complex numbers and other things, and something that you have, like a token or a ATM card, and something you are, that is a biometrics. That is, you can use your fingerprints, or you can use a facial recognition or something that you already are, right? So this should be the first principles. The systems which is part of the internet must have some way of authenticating who it is communicating to. Got it? So there are a lot of things we can keep talking about: the passwords, how people hacking the password, dictionary attacks, and how this becomes kind of a weak when we are using just the username and password. So we are moving towards the multifactorial authentication. Like, just a password is not enough. So when you are doing a username and password, and then your system has to do something else, like you're sending an OTP or sending a push notification into some other device. Okay, in which case it's kind of, you're not relying just one of it, rather the combination of this, like a password, username, and then another push notification. Okay, so that is number 1 aspect, first thing. The 2, authorization. Okay, so you got authenticated yourself that you are so and so to your bank, and then what? So each one checking whether the user has a permission to conduct some action, like your identity versus authority. So you went into your bank account, you cannot go and take a file of somebody else's. The bank may have like hundreds of thousands of other accounts. So your session where you are talking to the bank account, you should not be able to anything with other files other than yours. So your permission is given only to look at your account, right? So even in some cases, you may have a joint account with your spouse or your daughter or whatever, and then each one will have a primary authority. So this person can view only this account, right? So the second important concept in the security is the authorization. Once the user authenticate himself, then allow or give him certain permissions. You can do only XYZ action, or only XYZ records are visible to that person. So that is the number 2 concept. So there are systems like the Unix, Linux, that we already know these permissions like read write permissions, executable permissions, all that is how that is being implemented is a different story. But for you now, I wanted you to just remember this second important concept, authorization. The third one is confidentiality. What is confidentiality? Like when the content of your communication or a data should be secret. See, when you are transferring something, we don't want to send that in a clear text so that somebody eavesdrops or somebody interferes in between should not be able to just read that and know what is going on in there. So is the example like how is the password validator, for example, say in a database, so in a bank. So if your all your password, for example, when you are typing something, how are they validating? They should have somewhere stored it, right? So it may be in a disk or in maybe in some memory, some flash memory. But imagine if they are just storing that as a clear text as if you were typing it, and if the disk is stolen or if somebody kind of hacked into that, all the passwords will be stolen. Everybody, the people will get that. So we need some amount of confidentiality. What we do there is we kind of do a cryptographic encryption of that, like so we don't just store it like a clear, we just put some algorithms into that so that like some mathematical formula will convert that into something which cannot be easily read by human, and it cannot be reversible unless you know a key or something like that. So the confidentiality is to keep the content of the communication, or whenever you store the data, that should be confidential. Okay, that is the third pillar of the security. Got it? Okay, let's go to the fourth one, the data integrity. Data integrity equals to no corruption. That means, like, say I send a data from person A to person B, or A to a bank, or when you're communicating to Amazon for ordering something. So how do you ensure while the data is communicated without being modified by that? So that is important. The integrity of the data that is going from point A to point B is so important. So what we do for that is things like hashing, putting a checksums, and message authentication codes like MAC. So these are all needs to be done. This is the fourth pillar of the security. All right. So we got authentication. You said who you are, and then you have a permission level to authorize what you can do. And then the third one is confidentiality, that the information is confidential. And fourth, the integrity. All right. So what is the other one? The accountability. It is to ability for the system to determine the attacker versus the principal. Say when you are getting a data from somebody, or when some action is happening within an internet system, there should be a way, the system should be designed in a way that should be easy to identify, is this a legitimate user doing it versus a hacker doing it. So there are things like a secure timestamping versus OS versus network, or the data integrity in logs and audit trials must not be able to change the trials. So these are all this is the most important aspect of this accountability. Otherwise, the attacker can cover these tracks, like he can act like a legitimate user and do so. The accountability is your fifth pillar of the security, right? The next one is the availability. So yes, we did all of this, like authentication, authorization, integrity, confidentiality, all that. But if your system is so slow and the system is shut down for a lot of times, what use of that? So the uptime and the free storage is very important aspects of a system, a secure system. That is, the downtime should be so low and the web server's response time should be so quicker. So the things like adding the redundancy to remove the single point failure, multi-tracks, imposing limit, all of this needs to be done. So in the latter chapters, I'm going to talk something called denial of service attacks, which is basically the hacker will try to freeze the systems by simply like flooding the network with the packets, or by doing some improper malformed attack, in which case his goal is not to steal something, but rather he will make it painful for other people that the system is not responsive, the server is going to crash. So that is called DOS, the denial of service attack. So the availability is the concept where the system designer needs to think about that. If somebody is trying to attack you, can we have a redundancy? Can you have a redundant server to take care of that? All right. So that is your sixth pillar. The seventh one is non-repudiation. So what is this is undeniability of a transaction. Say, say when you are buying something from Amazon or you do a transaction with the bank, and then you go and say, I didn't do this. I didn't order this one. Why did you charge it? So, so that problem can happen. So there should be some kind of a digital authorization, digital signature done on that thing, right? So usually, like the normal transactions, it's not happening, but the credit card companies, they do it somehow. They have a digital certificates, a guaranteed evidence that this is the person who did it with a digitally signed statements. All right. Now, these are all the seven pillars I consider as the very, very fundamental concepts of cybersecurity. What are they? The authentication, authorization, confidentiality, data integrity, accountability, availability, and non repudiation. Okay, clear? All right. Now, let us see how these concepts work in a example. Let us say here they call Bob. So let us call here our Raja, Ram, or Krishna, our name. Okay. He's a bookworm. He wanted to order a book with Amazon, a website. Now, how these fundamental concepts are applied here? Say the number one, availability. Amazon ensures its website is running 24/7. So that is the concept availability. So they have to do authentication. This person, Bob or Ram or Krishna, whoever that is, has to enter his username and password. And that way he authenticates that he's the one who's really ordering that. And the third concept, confidentiality, is done by the browser. If you see his browser, this lock sign here, what this is it is sending whatever the information Bob is sending from his computer to Amazon is encrypted connection. It's not like if somebody is opening up somewhere in the wireless tower, I'm capable of doing that. You cannot see actually what is being done. So it is encrypted. So the concept of authentication is done by the browser design itself. Okay. And then the confidentiality. His browser also setting up this the encrypted one we said. The authorization, that concept, when Amazon has his name, Bob, okay, Bob is ordering and he's wanting me to ship it in the Prime, is he really allowed to do so? So he checks its database and see, oh yeah, he's a Prime member, he get a free shipping. So the concept of authorization is used here. Mhm. And then the data integrity, how is the data integrity is done? So in this case, the checksums, I don't know if you guys are familiar with the concept of checksum. It's simply like some kind of a mathematical calculation that a set of data has to map this, like when they calculate that. So the checksums are sent as a part of each TCP/IP packets exchanged between the SSL uses the MAC in this case. Okay, so the concept of data integrity is then the accountability. Accountability is that Amazon logs that this Ram, Krishna, or Bob placed an order for this particular book, Foundations of Security. Okay, now you're seeing like how this all these concepts. Of course, the non-repudiation is not done typically in the general cases, but this examples gives you how these fundamental concepts of authentication, authorization, confidentiality, availability, integrity, accountability, and all that is being implied in a very simple example here. I hope you guys are enjoying this example. Good. All right.
Yeah, very good.
Now, Das, go
Yeah,
ahead.
yeah, very much very much on to do.
Good.
Yeah,
Good. Thank you. Thank you. Yeah, it feels like sometimes I'm talking to walls. So it's good to have some interactions in
yeah,
between.
sure. It
Cool.
happens in
Cool.
the online sessions.
Yeah. I know. That's the thing. Like, I would rather than do the recording and send it to you guys to listen into, but this is the live. I wanted it to be live a little bit. So in between, just stop
The
by and say
participants are
something.
mute nowadays. Now, actually, they will be unmute after in because
I
it's
know. The other
cumulative.
extreme is like keep everybody will be talking, but at
Yeah,
least you guys, the host can talk in
yeah,
between. That would be nice.
yeah. We will.
All right. Cool. Um, so far so good. So now let us get into the next topic that I was talking about, the types of attacks. What are the different kinds of attacks that's happening? Look at this. Again, there are at least, I don't know, the 7 is coincidence, which I didn't mean to make it everything 7. Um, so the defacement, phishing, malware, insider threats, click fraud, denial of service, data theft, and loss. This is to give you, an idea of what are the different kinds of attacks that's happening in the cyber world, and what is the motivation for each of this when the hacker is trying to do that. Okay, the first one, defacement. This is more like for a kick of it, right? This is not like you wanted to um, steal some money or get some account stolen. This is more that the hacker want to show off his ego. Like, say, for example, in the 2017 election. By the way, guys, the election is going on in the US. I need to go for voting just after this. So, in 2017, the Donald Trump had a campaign thing. This is very high sensitive thing like website. A hacker from Iraq put this notification saying like nothing is impossible. Peace from Iraq. Look at that. So this is what this is an example of a defacement attack. That guy is what is he going to gain? He's just saying that hey, I can post anything in your place, right? So that is the kind of thing so happening sometimes. So if say imagine that the CBI has its website and somebody from Afghanistan put a, hey, I'm a Taliban, how are you doing? So that that will feel like you know uh, somebody is intruding into your network. So I'm making it a little lighter and joking, but actually what the point here is, even the hacker is doing for the kick, it is that the network infrastructure, the whatever the communication channel that is being used, being hacked, the hacker is capable of putting his stuff into us. So that is the kind of attack that's called defacement. The second one, which is the phishing, which most of us were very familiar with. If you have your email, and you will often see that as if, hey, verify your account. I am calling from XYZ bank, the SBI or the Indian bank or the Chase bank or whatever. And then if you're, it will look like a legitimate site, but it's not really the site. In that case, you go and open it and they will ask your credentials, say, what is your username and what is your password? And then if you're not savvy enough about the security and you think your bank is asking you to verify XYZ and you type it, the hacker will be like having his information, his fun time. So that is phishing. This is usually like sent through an email with the link. The links may be like here as if it is from the bank. So this is happening all over the world, even most advanced countries. Think about like we have people like in India, we are making it digital India, and it is a lot of education needs to happen. People just got a phone and they're not aware of all of this. It's very easy for a hacker to do a phishing in places like India, right? Even it's happening in US, Canada also. I'm just saying it's more possible, more vulnerable in those cases. All right. The third one, we're talking about the malware. Malware is nothing but a malicious software. There's a lot of variations like a spyware, ransomware, clickbots, etc. The forms of distribution, we can do a email attachment, Trojan, drive-by download, and link to drive-by phishing email or a worm and a cry. So all this is the malware. So the motivation here was everything. So one, he can make a denial of service, he can make your system useless, and he can kind of, if he has an internet connectivity with your system, he probably, the hacker can steal the information that you have, and any of the thing can happen with the malware. The next one, the insider threats. Insider threats, even though it looks like more of a social engineering, the social things is a lot of times humans are humans, people are people, right? So you work in a company, you work in a bank, you can always find somebody who is willing to compromise the integrity. So he's willing to give you, okay, particularly, if you give him some money or corrupt or something, people can leak. Yeah, where a system designer, a cybersecurity designer, not only should indulge only in technical aspects of it, people should also think about social engineering. Social engineering, what I mean by that is how an individual human being may do that. And that is where the separation of the privilege, the least privilege principle in the design should work. Meaning, if an employee of a bank works, he should be given a privilege only to the records that he needs. He should not have access to all the records. Okay, so this is, I'm trying to link these principles into the common the threats here. The next one was the click fraud. This is also so famous nowadays because of the targeted ads. There are a lot of things happening, right? So the pay per click ads, like if there are like million clicks happened on particular thing, the ad will be get paid. How about a hacker creates a robot, a botnet that will go and click in multiple computers? So in which case, the legitimate user is not really seeing that the competitor's ad and this ad. So the site publishers could click on the ads to get a revenue automated through these things, right? So that is another kind of thing. So I'm listing all of this to tell you what are the different kinds of frauds and the different kinds of hacking that can happen. It's not just the phishing, all these 7 things. And then I already touched upon this thing, which is the denial of service, which is the attacker intrudes the server with the packets. Say, for example, I will tell some more detailed example of a simple web server where if you understand how a web client works with the web server, the acknowledge packet and waiting for something to happen, these people, the hackers, can just keep sending the packets, and which will kind of holding the entire bandwidth so that the legitimate user won't have any bandwidth at all. So that is the goal for such a attack is it's not to steal something, but to make the system useless for others as a denial of service. That is also happening all over the world a lot of times. Particularly, this is for the financial and e-commerce vendors will face that one. And this can be automated also using the botnets. And then the data theft and data loss is, this is kind of a common thing. There is an estimate and surveys that billions of consumer records were stolen, and most state laws require a disclosed theft. These are all some general rules in the Western countries, and I don't know what is happening in India, but in general, if a company has a record stolen, there is a state law here that they have to report that to the people. Hey, this has happened, so be careful with that. Your password is stolen, somebody is taken, and so you need to better change all that. So this is a law. If they don't do that, and the business will be penalized in that case. Um, so this is the other side. So I think this, I kind of gave you some insight into what are the different kinds of attacks: defacement, phishing, malware, insider threats, click fraud, denial of service, and all that, which you will have um, at least some ideas. And one more thing which is missing here, I wanted to underline, you guys. This is a little scary though, um, where I am specializing in the embedded systems and the mission critical. the Internet of Things, smart devices. Imagine that there is a electric grid in a very critical places, and that is being controlled by a smart device, yeah, smart relays and smart. It's a complex electronic device which is controlled by some kind of a commands from there. If a hacker gets hold of such a critical infrastructures, so they can, unleash havocs in people's life. Okay, they can kind of keep shutting down the electric grids. They can shut down the power plants. So those are all kind of the fear that we have. The modern life of us is more and more relying on digitizing it and relying on the internet. So comes the fear of like what the hacker will do to that. So that is another aspect of the thing, the type of attacks here. All right. So now that you know the concept, the fundamental pillars of the software security architecture, the types of attacks that can happen. And then the third thing that I wanted to talk about is the principles, the design principles of how the secure design should do. And then I will do an example. How are we doing with time? Thus, looks like probably running out of time.
Yeah, you can take your time because only serious the learners are in the meeting. So,
Okay.
so
Yeah,
you,
I may run over like a couple
yeah,
minutes
time
or
is
10
in your
minutes.
liberty. Yeah.
Yeah, but I will do. But guys, if you're bored, let me know. I'm not going to take a long time, but I'll be doing little more design principles, and I will give you some interesting example of your hacking, and we will close it. Okay.
Okay.
So this is again a set of principles that people should use when they have uh, thinking of designing the whole system. When I say system, it includes everything, not only software, it includes hardware, the networking infrastructure, and the data servers, storage servers, cloud services, and all that. So these are all the basic principles that one should follow when designing a secure system. The principles of least privilege, defense in depth, securing the weakest link, fail-safe stance, secure by default, simplicity, and usability. Let us talk about that a little more with some examples, and then we can go to our hacking example, finish the seminar. Okay, right. The first one, what is the principles of least privilege? We said is that when a person has an access, give him the least possible privilege that he needs to do his job. Otherwise, that is the security principle number one. Say, let us take a case of a simple web server, the basic HTTP web server, which is to illustrate this concept. Um, so if you look at the code, the HTTP communication protocol is used in the web. This primary function is to establish a connection with the server to transmit the HTML pages between the browser and your the application. Okay, so let us say he has a typical request, get request HTTP, and then your server responds with HTTP, yes, followed by the document contents. What does this mean here? We are saying, let's go to the next one. In the web server, if the simple web server run under the root account, if you guys are familiar with that, root account means is the admin super user. He can access any file on the system. The serve file method, he can go to here all the way up to the root. If you guys are familiar with the Unix and Linux systems, we store the password and username under the etc shadow, right? So if the simple web server is implemented at the root level, and then the serve file method can go to any place above this, and then they can have an access to this. So here is the principle of giving a least privilege. So while implementing the server, this method, we should not give the root access to that. That is the principle I want to do. Otherwise, your password will be stolen. So there are methods to do that. So you can check when somebody is trying to access the file, see, hey, are you really authorized to take that? What is your working directory? And this working directory, if the requested file is under the directory or above. If it is above, I'm not going to serve you. So checking the path name. Got it? So this is the idea that you need to give the least privilege for the given operation that is to be done. That is how your server should be designed. And that is how our internal architecture should be. So that is number one principle. So number two, diversity in defense or defense in depth. That means you don't depend on just one aspect of the security. You need to have multiple things. Say, for example, the variety of OSs to defend against virus. And you don't have just one firewall, you have another firewall also. So this is what called defense in depth. All right, weighing in the extra security thing. So you get like more than one firewalls, and you have, say, for example, one variety of OS on Windows, Linux, or whatever, and then some kind of redundancy. So the defense is really not going to uh, depend on just one mechanism, rather apply multiple mechanisms to do. That is the principle two in designing the thing. And then securing the weakest link. The information system is only as strong as its weakest link, meaning you can be technically so strong, you get the most efficient firewall, but if you have, for example, the weak password and people are writing their password in their notebook and keeping the notebook at the office, what good are you? So, so we should be like thinking about how do you secure the weakest link. So the principle is identify what is the weakest link in the system and how do you secure that. Okay, things like a social engineering, the buffer overflow attacks, and all this. Each one of this will take another 2 days to explain, guys. I'm really sorry that I'm kind of going through so fast on this, but the goal for this today is to give you the landscape and the context and the basics. And if you really are interested, we can have another session later. Talk to us later. Okay, good.
Yes, yes, we can have.
Yeah. So that is that. And then the fail safe stance. What is this? Okay. With all the security measures that we do, you have to assume the hacker will still get in. There is no guarantee of any security system, the 100% you will be safe and you cannot. So if the failure ever happens, how do you be safely exist from that? So in a real world situation, I will say your elevators, right? So the power cut is happening all the time, right? Maybe it's very less now. There are some times when I was visiting India, it was pretty common. So what I mean by the fail safe stance here is if the elevator stops in the middle because of the power cut, you should have a way, it should be designed in a way, it should be expecting the power failure. In a power outage, you should be able to grab into the cables and guide rails should be able to get you out. So similarly in the software system, say your firewall was breached in, somebody got on inside, and you have a system to know that okay, the firewall is breached, some hacker came in. What do you do? So you don't accept any more call anymore from the system. So you can either reboot or restart or you just stop the whole thing. So that is what the concept of fail safe stands in the security. Got it? Good. And then the secure by default. When you design a system, like, there are like n number of features, hundreds of features we have. We don't have to enable all the features. So there is this concept called attack surface and is directly proportional to the vulnerability. The more the features you expose to the users, the more probability that somebody will hack into. So when you are releasing a system, be it a operating system or a software update or a banking software or whatever, you enable only the minimum amount of features that is needed for the 80% of the users. And then on the need basis, enable the other features. That is secure by default concept. Okay. The simplicity and usability. So this is always the problem in the security designs that we say. When we put together all the securities, the system becomes almost unusable. It is so hard. Say you tell people your password should be at least 8 characters long, one should be capital and one should be smaller and should have some special characters. The number should not be there and blah, 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 blah. And it's so hard for people to even have a password. And nowadays we have password for everything. 3 bank accounts and then one Amazon account and then school account, college account, daughter's account. So how many passwords somebody will remember, right? So people will maybe then they will work around, they will write it somewhere, and then it becomes a week. So we need to be like little more simple. When you design a security, it's not necessarily a complex thing that we always talk. It should be simple. Security holds likely in a complex software. Simple design is easier to understand. Okay, centralized piece of the code. That means like all this validation should happen in one place. When you do a code review, the validation should not happen in 100 different places, right? So these are all some concepts of the simplicity and usability. All right. So the design principles that we talked so far is a defense in depth, securing the weakest link, fail-safe stance, secure by default, simplicity and usability. So all of this, like I can go on explaining. It's we're running out of time, but I will give you a few more kind of a picture on the software life cycle and how all of this is used in the industry that when I'm working on. So this is a general flow of a software development life cycle. So the requirements and use cases are gathered and the other architecture and design is done, the test plans, the code and implementation, test and test results, and then feedback from the thing. This is the traditional software life cycle. When we do a secure software development, here are the things that we need to do. That you need to factor in the security requirements right from the beginning of the requirements. That is, you don't build a system and then say, hey, I need to add a security. No, the security requirement should be given before even you start coding. The test plan should be done before even you start coding. And then you do all these penetration testings and the phishing testings and all the testings before you release to the thing. And you should always have a way to get a feedback from the field and go back to the requirements and the security things. I know I'm talking so abstract, so high level, but this is what it is for now. And we can always think of coming back to this, guys, because we're already running out of time. And I'm going to go for the example of an attack and we can close this. Okay. Because I have so many here and I don't think I can be covering that, but maybe just one example, right? The denial of service in the simple web server we had. Say, for example, um, the vulnerabilities often is due to the bad error handling cases. Say in a simple web server case, so if you're reading a buffer read line, so this is a code inside your web server. So if you're not checking for a null character or a carriage return, a hacker can take advantage of it. Hey, he can send you a command which has just a carriage return, which means in a function, the simple web server function, when he's reading that, he is keep on waiting for a token when the tokenizer in the server is looking for something to tokenize. He is getting a blank from the hacker, and that means an exception, in which case the hacker, the web server will be waiting forever infinitely, which means the server is not usable for other people. Got it? So this is an example of if your requirement of error handling is not designed properly, this is what will happen. The hacker will do a denial of service attack on you by sending some weird nonsense, and then you are not able to process that. So in a normal user won't send that. You don't expect that. But the hacker will send it just to make sure your system is going to crash. So the code here, how the properly designed secure software which should to do is you should expect the unexpected. You should expect a blank input from the user and then do a try catch solution here. Meaning, like if there is a null and I'm not going to serve you, I'm going to say that it's a bad request and close the thing and move on to the business. So this is the right to design example of expecting the bad things from the hacker, and you have to design your server and your software to handle those errors. Good? Right. So that is an example of that. So the one last application example I will show you guys before you go to your dinner. Probably, I don't know if you guys done your dinner or not before you get to your bed. One last thing we'll do, and I'm going to skip all of this because this is going to take another day, and I don't have time, and you don't have time. I will do um, one example. So, but the summary though, we have talked about the types of attacks, some example design principles, and how we should design a system so that it is resilient, even if you're expecting a hacker to do that. Okay. Now, this last example, I'm going to talk about an application security attacks and maybe little defenses. It will take maybe 5 minutes and we are done. Okay. Good. Let's take a web application. What is a web application? It's a collection of programs, right? Used by a server to reply to a client, a browser request. And the HTTP is stateless. What I mean by that, it doesn't remember all the states unless the server is asking it to do. So to conduct any transactions, we need the apps to have a state, the memory of what it is doing. And the state information needs to be sent from the client and we echoes back the feature request. Anyway, I'm talking too much abstract here. Let's take an example here, guys. A good example that is somebody is ordering a pizza. Probably you have done it several times. Okay. And how this can be attacked by a hacker. So take a pizza delivery website and the web application for delivering a pizza. Okay. In our case, you can replace this for a masala dosa or a chicken biryani, whatever you want to. So you are ordering with Zomato or Swiggy. You don't have to be a particular thing. But the concept is there is an online order form, order.html. Say the user buys a pizza or a biryani for $30. You convert that to your rupees, maybe 300 rupees. The confirmation form then generated by a confirmation holder script, which asks the user to verify the purchase. Okay, the price is sent in a hidden form field. Then the fulfillment, submit the order script, handler uses a order, received a get request. All right. So now this is how the pizza website code looks like inside. That is, the total cost of the pizza is 300. Are you sure? Would you like to order? And then the hidden field will give you the price value is 30. And then the two buttons for yes or no. And the submit order will go and say if the pay is yes, and then you do authorize the credit card charge for the price. If that is success, then you settle the transaction with that price and dispatch delivery. So in a system like, it will give a notification to the Pizza Hut. Okay, that delivery person will see that, and then they will take and come and tell the user card. If your credit card is declined, then the user will get your credit card is declined. Okay, so this is what the submit order script looks like. Now, look at this. Das, can you hear and see?
Yes, very much. Very much. Yes.
All right. So this is interesting, simple example. That's why I want to make sure people are able to see this. So the web browser from Bob or from Krishna or from Das is ordering a pizza or a biryani. It's $30 or 300 rupees, right? And then this is what, let us consider the attack scenario. The attacker navigates to the form. This is the order form. We have how many pizzas would you like to buy? One. And the credit card number you submit, right? So now, before submitting the credit card, so this is what is happening. The attack scenario. Here, if you look at the view source, you cannot change here the price. But if you look at the browser view, and if you can see as a developer and look at the view source, right? You can don't go and try these things. People already solved these problems, but, but this is just an example. Like in the olden days, these are all being done. So to tell you how these attacks are happening, I'm showing you. So when you view the source, this is how it looks like. The total cost is 30, but this is in the field, the input type hidden, and 30, 30, 30, this. And then the attacker can go and change this to maybe 1 cent or less, 0.001, and he can reload the page. Ta-da! The browser sends the request, and he will get the uh, pizza for 1 cent, 1 paisa. This is what is happening. Okay, this is a typical example when people can attack on the application, because the hidden form variables are essentially in clear text. Because here, if you look at the clear text, I mean, he knows it is $30, and he knows this is where you need to change. So he's going to changing this 30 into 0.01, and so the modified price is going to be this, and there is no checking on this on the web server if the way it was written right now, because this is being done at this point. So the credit card payment gateway doesn't care what it is. So he's going to just charge 1 cent, and then attacker modified this. So this can be like done like in an automated fashion. So you can kind of intercept the traffic in between and continuously do that. People have done that here. You know, so automated that using the curl and widget and then all these programs that will kind of read this one, and they know like, okay, this order is this, okay, display and put this value. Now you see this, what is happening. So how do you solve this problem? This happened in the olden days, not anymore. So what they did is, instead of sending the clear text of 30, they would rather send a session ID now. For each of these transactions, you send a session ID, which is basically a hard to guess, randomly generated 128-bit ID. And then this one will be sent in the transactions rather than the number 3. So the hacker needs to find out, they cannot find out what it is, uh, where is the price done, and what to change. Okay, so that was a example, the last example, guys, and that was kind of giving you a little, the taste of what the hacking world, what the cybersecurity is. You know, the more, I think that kind of concludes my examples, but this is not what my original intent is. I wanted to talk to you about more advanced things like cryptographic, and also the quantum computers which are going to come, how that they're going to like, nullify all the security algorithms we have. Like if you can make a calculation million times faster than what your traditional computer is doing, which is going to come in next 10-15 years. All of the security we do right now is going to be useless. And how do you manage that? How the hardware companies are thinking about that, and what kind of algorithms they're putting. So they're all so interesting, but I was little afraid to start with such a topic in a first 30, 40 minutes. So I rather decided to stay with the very, very fundamentals. And I hope this is going to be meaningful to you guys. If I have created some interest in you about this whole thing, and if you are looking for a particular advanced topic, talk to Das, Nanadas, and I'm more than willing to dive deep into one of these topics in the future time frame. Okay. This
Yeah, that is
concludes my
perfect, Jamil.
discussions today. I'm looking for any questions or comments or suggestions, and I will pause right now. Thank you. This
Yeah,
is
any
my
questions?
favorite slide here, questions.
Yeah,
By the
any
way,
questions
guys,
from
I do
audience?
love my dog. I have a dog. He's waiting outside my door right now
Can I
for me
show
to
it out?
finish this. Yeah, his name is Kobe. He's
Oh,
he's just waiting outside my door, listening to this. All right. Any questions you have?
I hope I'm audible.
Yes, you are.
Yes.
Okay. Good evening, everyone. Honorable dignitaries, distinguished guests, and dear participants. On behalf of SRM University and organizing committee, I felt immense pleasure to propose a vote of thanks to our eminent Mr. Thiru Angayan, engineering manager from Texas Instruments, USA, who spared his time from busy schedule to give this webinar on software design and advancements in cybersecurity trends. This session has truly enriched our understanding and opened our minds to new perspectives. Although I'm a first year student, I'm still quite new to this field. Today's session has given me and my fellow classmates an inspiring glimpse into the field of cybersecurity. He introduced us to the fundamental concepts and illustrated them with relatable examples, making complex ideas accessible. One of the most captivating parts of the presentation was learning about different types of attacks and secure design principles, which were explained with clarity and depth. The attack scenario he described through the pizza ordering example was particularly an eye opener. It truly brought to life the importance of secure design in a way that felt tangible and real. I feel like I'm sitting in an engaging classroom again. We extend our heartfelt thanks to Mr. Angayan for explaining the concepts so thoroughly and engagingly. Then I would like to further extend my thanks to our beloved director, Dr. Manoranjan Kondra, Director of Online Education, SRM IST, who always encourages us and provide the opportunity to organize such events. Apart from that, I utilize this opportunity to specially express my deep regards and gratitude to the management of SRM for organizing this program. And thanks to our program coordinator, Dr. M.L. Gnanadasan, MBA, SRM IST. Finally, my deep sense of appreciation and thanks to the participants who choose to be live with us and attend the webinar with great enthusiasm and made it as a successful event. Once again, thank you all. Over to you, sir.
I think thanks for wonderful vote of thanks and thanks for Kalima and all the listeners who are very patient listening and inviting all the participants to the cybersecurity. My special thanks to Mr. Sidhu Anjay.
Thank you, Das. Very welcome. It was really an enjoyable time for me to be in discussion with you all. Thank you all.
Yeah,